Hi, this is Dr. Pat. This is part 3 of related rates. Going to do another problem for you. So we've got the Cobb-Douglas production model here. You might see this in one of your business classes later on. So one of the first things that we do in solving these types of word problems is we need to identify what our goal is. What are we looking for? And like a typical math problem, the last sentence is really what I'm looking at. And I'm seeing what we want to find is the rate of change of the number of employees. And so remember that in this production model, L represents labor, so that would be the number of employees, and K represents capital, and P represents production, the production level. So for us, we are looking for derivative because rate of change is the derivative, and since we're talking about employees, we want dl dt. That's what we're looking for. So we want to make an equation. We got to find some equation with L in it, and we're going to take its derivative. That's eventually what's going to happen. Okay, so now what information do we have? Well, we've got that production formula, so we've already been given the formula that we're going to take the derivative. That's just one of the strategies that we have, is that when you're looking for, when we have a related rates problem, you have a formula with many variables in it. We're going to take the derivative of this, and when we do that, we're going to create a dl dt with that L there. And so that's what we're shooting for. We'll play with that. Some information we also have 20,000 is our production level. So that's at P equals 20,000. The other thing that I'm looking for is the word here, maintains. Okay, maintains means that our production level is not changing. And when our production level doesn't change, that means the derivative is equal to 0. So we get automatically dp over dt is equal to 0. That derivative of production with respect to time will be 0 because we're maintaining, we're not changing that production level. Other pieces of information, we have a labor is 25, we've got capital is 65,536, so those are nice straightforward numbers. And we also have dk over dt is equal to negative 1,000. Our capital is reducing, so that's a change word there, reduction, changing, it's going down, it's decreasing. And so that's why we have a negative 1,000 because of the decreasing, and we're using dk because we're talking about capital. So that's our information. Some of the relationships we're playing with. Well, we have a formula here. So in the upper left-hand corner, we have that formula. And so whenever doing related rates, I do want to take its derivative because that's what we're going to be playing with. You find a formula that relates all the things, and then you take its derivative. And we're looking for dl dt is our goal. And also just remember that when we're playing with different variables, so we've got P, L, and K in this formula, and then we're going to take the derivative with respect to time. Now we're throwing in the variable T, and whenever you do that, you have this extra step when you do the derivative. You have to do the derivative of the variable. So that's the key thing about related rates. It's a chain rule idea. Okay, and so our goal here is we want to take the derivative. We're going to use the product rule because capital and labor, they're multiplying together in our formula, so that's why I'm using the product rule. We've got basic power rule when we actually do the derivatives of those things. And then here's the key point. Plug in your values after you do the derivative. You plug your values in before. When you take the derivative, you could lose some information. So basically my recommendation, so that you're ready for all kinds of situations a math teacher or your business examples can throw at you, is plug your values in after doing the derivative. And then we'll do the algebra and solve for dl dt. So that's the key there. That's my approach that I'm going to use. So let's do it. All right, so the key thing here that I'm looking at is I got L times K, so that's two things multiplying, so that's telling me product rule, and that's what I'm doing here. So the 250, that's a constant, or a coefficient, excuse me, that's a coefficient, so I'm just bringing that along for the ride. I'm going to do the derivative of the L first, leaving the K alone. So when we do the derivative of the L, it's just a straightforward power rule. Bring the power down in front, multiply, and then subtract 1 from the power, and then because this is a related rates and we're doing the derivative with respect to t, we have to do the dl dt. We have to do the derivative of the actual variable. And so that's the derivative of the first part. Then plus, once again, the 250 comes along for the ride. This time we're writing the L. We're not doing that derivative. We already did that piece. And then it's the derivative of the second part. And so once again, I'm bringing down the power in front, subtracting 1 from the power, and then doing the derivative of the variable. And so that's the product rule with the power rule, and technically the chain rule, because we're doing the derivative of the variable at the end. Okay, and so what we want to do is now plug in our values. So I took all the values that we identified earlier, just throw them into the formula there. And so just kind of, yeah, as you can see, I've got labor is 25, so I'm just plugging in 25s for the L, 65,536 for any time I see a K. We had dk dt being negative 1,000. The 0 over here in front was because we're maintaining production level. It's not because we're finding our max or min. That was a different types of problem. That's optimization. What we're doing here is we're just going to solve for dl dt, but dp dt was equal to 0 in this case. Sometimes that can be equal to another number. It doesn't have to be 0. And so that's what we're playing with right now. And then our next step is to solve for dl dt. So we're just going to kind of do some number crunching there. Basically all the numbers with the dl dt, when you multiply these pieces with that 65,536 to the 0.25 power, when you multiply that, I got 400. And then basically all this stuff together rounds off to like 430. It was something like 429.89, blah, blah, blah. And I thought I'd just make it a nice 430. And then next step, let's bring the 430 over to the other side by adding, and then, and then divide both sides by 400. And so I'm looking at 1.075 employees per year. And so there's my final answer. I found out what dl dt is worth in this example. Hope this helped, and talk to you another time. Thanks. Have a good day.